All right, adding vectors the triangle method. So this is what you want to jot down. It's easy to add vectors when it's a tailwind. You just add them. Headwind, you just subtract them. It's a little more confusing when you have what's called a crosswind example. So we have something like this. It says if a plane flies due east at 100 kilometers per hour and a wind blows northward at 25 kilometers per hour, draw the resultant vector representing the plane's true velocity. So the question here is basically you have a plane flying and you have a wind blowing at a 90-degree angle to it. And here are your steps for success using what's called the triangle method. Draw the first vector. 2. Start drawing the second vector so that its tail begins at the tip of the first vector. And for right now, just jot this into your notes and then we'll do this example and it'll make more sense. And then finally, number 3, draw the resultant vector starting at the tail of the first vector and ending at the tip of the second vector. And we're going to do this one, it'll make sense, but a couple of things. You're going to have to use SOHCAHTOA and the Pythagorean theorem to do problems like this. And if you remember back to math class, that means you have to be in degree mode. So in physics, we're always in degree mode. And that's a little tricky because if you're in pre-calc or calculus, a lot of times you'll be in radian mode. So on our test, just make sure if you ever have SOHCAHTOA in Mr. Lent's class here for physics, you have to be in degree mode. So go ahead, hit pause, sketch this down, and then we're going to do this example. All right, so we have our example. It says a plane flies due east. So I'm just going to put a little key up here. So we have never eat soggy waffles. All right, so for vectors, I always do that because it helps, but a plane flies due east at 100 kilometers per hour. So let's just go ahead and say, okay, here's due east. No straight lines here. Shaky coffee hands. So this is the first vector. So this is 100 kilometers per hour. So that's the direction of the plane, kilometers per hour. So we draw our first vector. And then step 2 says, wherever you ended that first vector, so here's the tip of the first vector. Now we want to draw the second vector. It says, and a wind blows northward at 25 kilometers per hour. So when I draw this one, it's going to be 1/4 the length. So it's going to be something like this. And the reason why is because 100 kilometers per hour is going east. And then now this is the 25 kilometers per hour going north. So in this case, you can't just add these two vectors. And the reason why is because one's going east and one's going north. They're not going the same direction. So whenever you have two vectors that are at a right angle to each other, which here's your right angle, you're going to have to do this triangle method where you draw the first one. And then from the tip of the first one, you draw the second one. And now the resultant vector, I'm going to go ahead and change pen colors here. Let's go blue. The resultant vector, or the overall speed of this plane, is going to be from wherever you started to wherever you ended up. Crooked lines. So somehow we need to find this blue vector. And some of you right away might be thinking, I know how to do that. And to add vectors, if they're right angles to each other, you use the Pythagorean theorem. So you're going to do 100 squared plus 25 squared, and then square root that. And I already did that, and I got that that vector would be 103.1 kilometers per hour. And technically I should put in km per hour, but my handwriting is atrocious, so I'm not going to write more. So that's the magnitude. So we'd say, okay, that's the resultant r. That's how fast that plane's going. That's the speed of the plane. But some of you might be thinking, well, hey, a vector has a magnitude with a direction. So this plane is going to be going 103.1 kilometers per hour. But somehow we need to get this angle right here. So we're going to need to get that angle. Boom, theta. And the reason we have to do that is because this resultant vector, r, needs to have a direction. So to get theta right here, we're actually going to use tangent because we have opposite and adjacent, so O and A, and it's going to be inverse tangent. So you're going to do inverse tangent of 25 over 100. And when you do that, you're going to get 14 degrees. So this plane is flying 14 degrees. And this is a little bit of a weird notation in physics. You're going to say 14 degrees north of due east. So basically, it's 14 degrees above or north of due east. And that's a little bit of a weird notation. Our book likes to do it that way, so I'll write it that way. but it's not too bad. So whenever you're doing the Pythagorean theorem back in the day, and you're like, whenever am I going to use this? Well, the engineers use it all the time when you're doing vector addition, when you have two vectors, they're at right angles to each other. All right, last but not least, the out the door vector question, and then I'll start with the warning at the bottom. Warning, do not try this at home. I actually have a link to a Mythbusters where they do this safely, but do not try this at home. It says, Frederica Physics, spelled with a PH, drives 100 kilometers per hour in a truck. So Frederica is in here. She's driving the truck, and they're going 100 kilometers per hour. Meanwhile, Freddie, so here's Freddie in the back, safely sits in the back of the truck and throws baseballs off the back at 100 kilometers per hour. How fast would the baseballs be going as they leave Freddie's hand? So essentially you have this question. You have the truck going this way at 100 kilometers per hour. You have Freddie, who's got a perfectly calibrated pitching arm, who's going to throw it at 100 kilometers per hour. And the question is, ooh, I hear Finn trying to break into my office, but I'm recording a video. So you have truck going this way at 100, Freddie throws this way at 100, and the question is, what's the overall or resultant speed of that baseball going to be? And I gave you some choices. I said 0 kilometers per hour, 50, 100, or 200. So go ahead and take a look at that video once you feel like you've reasoned this out and you understand it. It has to do, in this case, well, I don't want to give any answers away, but it's either going to be vector addition, vector subtraction, or the crosswind kind of example where they're at a right angle. So you think to yourself, is this kind of a tailwind example, headwind example, or crosswind example? And then go ahead and take a look at the video to see if you're right. All right, that's a quick little review of vectors. Have a wonderful day. Go Physics All-Stars.